Hello, everyone, and my wonderful followers all around the globe. This is the YouTube channel at What Impact 6981. I'm your uncle, Taiwo Oluwagbemsoye Ige. Thank you, everyone, for the last video edition that was released. Your comment, the likes, the subscriptions has really helped us to go a long way. And we promise to release out the second phase of the video in order to conclude the topic that we have begun in that last edition. This channel promises to be highly educating, informative, and highly inspirational in all the contents that will be released out from there. All right, let's go together into the classroom. All right, welcome back to classroom. Calculation of relative atomic mass. Chemins 002 at what impact 6981. Okay. Let's move straight. We are familiar with the first thing, isotopy, isotopes, nuclear symbols, and examples under that. Okay, today now we move straight to the point. What do we understand by the relative atomic mass? This is the mean or average of the isotopic masses. The mean or average of the isotopic masses. We have better understanding as we continue. Let's go. We can actually calculate the relative atomic mass of an element via the following method. One, if the relative abundance of the isotopes are given in percentages, it means P1 plus P2 plus P3 equals 100. The P1, 2, and 3 represent the percentage abundance of the isotopes of a particular element. And the summation of these always equals 100, always equals 100. No matter what the isotopes of that, the number of the isotopes of a particular element is, the total sum of it must be equal to the weight of 100%. Let's take note of it as we continue. Now, mathematically, we can express that by saying the relative atomic mass of an element will then be P1 times A1 plus P2 times A2 plus P3 times A3 divided by P1 plus P2 plus P3. It's the numerator that will vary depending on the number or the percentage abundance of the isotopes that are given in the question. The denominator will always be constant because it's 100. Total sum of the percentage abundance always equals 100. So that's first expression that we can use in calculating the relative atomic mass of an element. Let's take note of it as equation 1. Okay. However, when the relative abundance of the isotopes are given in the form of ratio and not in percentage abundance. So if it is in ratio, we represent that one with R1, 2, and 3. And so the total sum of it is going to be the denominator, R1 plus R2 plus R3, which gives us a new expression. So the relative molecular mass using ratio would then be ratio of the first isotope times the mass number plus ratio of the second isotope times this mass number, on and on depending on the number of the isotopes that are given, divided by the total ratio of the isotopes that are given. So if it is 2, that would be the ratio of the isotopes of the two isotopes that are given. As if it is 3 and it is 4, you are going to have it as your denominator. Let's look at a very good example. Naturally occurring chlorine atom contains 75.0% of chlorine 35 and 25.0% of chlorine 37 by mass in ratio 3 to 1 respectively. And we are asked to calculate the relative atomic mass of chlorine. There are two things in this question, two ways to approach this question here, because of the data that are given here. One, we were given percentage abundance, in which we can use it to get the answer. Second, we can use the ratio, the 3 to 1, to also calculate the relative atomic mass of chlorine. So whichever one that we make use of there, we are going to get the same answer at the end of the day. But most often, your questions do not usually give you the two. So that's why I combined it together so that we can be able to put it into practice and be able to answer any questions that may come up anytime. Okay, let's go. The method 1 is analysis method. Let's go there. The percentage abundance shows that out of every 100 chlorine, 75 atoms have a mass number of 35 each, while the remaining 25 atoms have a mass number of 37 each, which means that 75 atoms of chlorine 35 contribute 75 times 35, which equals 2625. And 25 atoms of fluorine 37 contribute 25 times 37, which equals 925. And the total sum of that, we're going to add it together to give us 3550. Don't forget the denominator is going to be the sum total of the percentage abundance. And in our question here, we have two isotopes, 75% of one, 25% of the other. Add it together gives you 100, and that gives us the denominator. I told you that from the beginning, and the final answer is going to be 35.5. And I'm sure you are aware, you can remember this is the relative atomic mass of chlorine. Before we leave this side to another method, I'd like to remind you of one thing also. That question can come out, especially in our multiple choice question, and say, why is it that the relative atomic mass of some element exists in decimal number and not in whole number? The simple answer there is very simple, because such elements exhibit the concept of isotopy. And so before you can generate the relative atomic mass, it's going to be the sum total of you're going to take the average of the isotopes together. And that's exactly what we call relative atomic mass. And so that's why most of the elements that exhibits the concept of isotopy do have their relative atomic mass to be in decimal number and not in whole number. All right, continue with the question. If it is in ratio that we want to make use of, instead of the percentage abundance, it means 3 parts of chlorine 35 contribute 3 times 35, which equals 105. And 1 part of chlorine 37 contributes 1 times 37, which equals 37, and a total of 142. And so the denominator, according to our expression, is going to be R1 plus R2. So which is going to now be R1 plus R2, which is now going to be uh, which is 3 to 1, which is 3 plus 1 equals 4. So we have the same answer, 35.5. Now, using formula method, if we apply the principle, the percentage P1, P2, P3. But in this question, we will not be having P3, we will not be having P3 and A3, since the isotopes are limited to 2. And so the denominator is also, we are going to cancel P3. So we are limited to only this as our numerator, and everything will be divided by the remaining here. P1 plus P2, no longer P3. And so we are going to get our answer at the end of the day. Is that clear? The same as the first one, 35.5. Okay, let's then move on. If it is in ratio, you can see, let me just clean up this so you don't get confused. Let me clean the screen. Okay. So if we look at it together, that's the same thing we have applied. Relative molecular mass, the R1 is 3 times the mass number, which is 35. The R2 is 1 times 37, which is 1 times 37. And the denominator is 3 plus 1. And so we have 105 divided by plus 37, which equals to 142 divided by 4, which also gives us 35.5. Now you know how to calculate the relative atomic mass of an element. You have to have this assignment to do. An element X with atomic number 29 has 2 isotopes and Z, Y, and Z. Isotopes Y and Z have 38 and 34 and 38 neutrons respectively. We have to calculate A, the mass number of each isotope, and hence write the nuclear symbols. And B, percentage abundance of each isotope if the relative atomic mass of element is 63.5. Sure you have copied that question? All right. You can send in your answers or any other inquiries onto my email or WhatsApp 070-309-309-03. Don't forget to hit the subscribe button and share it with your friends. Thank you. I'll see you again at the top. Goodbye.